Going up a few directories, I'm going to go to melodic/resting. And here again, I've already done everything. Again, just like what I showed with that auditory visual data set, you would use a lot of the same options. You would do stuff like you would bet your data, you would check the TR, make sure it matches up, but everything else, all those other defaults are usually fine. Leave on motion correction, leave on automatic estimation of components. And registration, just do that the way you'd register any other data set. Okay, so within here, again, let's see, filtered func data.ica is, sorry, let me go up one, and again, open up one of these things with Firefox. So this is what I would see if I were just doing it from the GUI, but I've already done it, so I already have these output files. I'm just going to look at them again. So again, look at registration, make sure this all looks okay. And then in ICA, you have many more components, right? In this case, we have a resting state data set, so we're trying to identify a resting state network. Now, there are a lot of slices, and they're only axial slices, so it might be kind of hard to identify which ones actually are the resting state network and which ones are not. Yeah. Right. So if we want to see this, just give me 1 second here. Yes. So if we want to see this a little bit more clearly, and we've already run all of our analyses, right? So this is all going to be in, say, filtered func data.ica. And notice here, we would have this melodic underscore ic.nei.gz. So this would be output after you've run your ICA analysis. Now, it might be easier if we can actually overlay that on a standard space in a 3-dimensional space, instead of just seeing a bunch of 2-dimensional slices, and looking for the resting state network that way. So flirt in melodic ic.nei.gz, and the reference is going to be my FSL directory in the standard folder. I'm going to use MNI 152 underscore T1 underscore 2 millimeters, and the output is going to be melodic flirted. I'm going to apply a transformation matrix because we already estimated that in our initial registration. And it's going to be in the above directory, example func2standard.mat. Okay, so this only takes a few seconds. And once we have that, we can then use FSL View to open up this on top of a standard template, threshold it a little bit, and then look for the resting state network. All right, so FSL View, again, we're going to be using the standard template as our underlay. 152 underscore T1 underscore 2 millimeters. Melodic, what did I call it? I called it melodic flirted, yes. This is just what kind of color scheme do we want. Red, yellow is pretty good. It's just like a typical heat map. And then this is going to be our threshold. So basically, the lower bound, let's say 3 or 2, that's going to be our lower z-score. And then 10 is going to be what the maximum scale is going to be for the top. Whoa, FSL there. 10 is going to be basically a standard for what the maximum heat is going to be. That was a really terrible definition, but anyway. So now that we have this here with volume, this is basically what we're doing with what we were doing with the HTML files, paging through those different independent components. Now we can just go through these different volumes to look at these different components in 3 dimensions, which is a little bit cooler, right? So again, we're looking for the resting state network, okay? And really, a lot of people just do this by hand, or they have a trained neuroanatomist do it, or they have me do it, which is a terrible idea, but I will do it if you pay me. So you just page through these, no, oh, okay, this looks pretty good, okay? We have a lot of this ventromedial, kind of more frontal PFC stuff. We also have some retrosplenial and precuneus activation. This looks like a pretty good map for a resting state. What some people will do is they'll have templates, right? So basically like a gold standard, so people average resting state networks across a bunch of people, have a really good idea about what it is, and then they'll say, I'm only going to take that one which has the most z-scores falling within that are above a certain threshold as opposed to outside of it. And you can look at this with, you can look at this by going to Tools, going to Toolbars, Atlas Tools, and then if you double click to the right of one of these, let's say the cortical atlas, so that there's the eye, now you can see overlaid the different regions. So you might want to say, well, I want to make sure that this is actually within a certain region where I think it is in standard space. So here, yeah, this is cingulate gyrus, anterior division. Okay, we're getting more into the frontal pole, but it still looks pretty good, frontal medial cortex. And then back here, I have a lot of activation, which falls within, say, the posterior division, and also some of the precuneus. Awesome. Okay. That was a lot. My vocal cords are very tired. I understand I gave you a lot of information, probably mumbled a lot, which pisses a lot of people off, but, well, find some other guy's blog to criticize. Anyway, I'm not sensitive or anything. So, that is in a nutshell, and I use that term a lot too. I use my hands a lot, I know. Not that I'm sensitive or anything. But that in a nutshell is how you would identify certain components after you run Melodic for trying to find resting state analysis. And the next thing that we're going to do is we're going to use those maps, those independent components, and actually try to do a null hypothesis test to try to find where different components are more significant, or we can compare them across groups.